Good morning, good afternoon. My name is John McHugh. I'm the product manager for Oracle Clusterware. I believe this is going to be the first of probably several rollout presentations through RACSIG describing the new features and functionality of 12c. Today's presentation has a very specific focus. It's a focus on the Flex cluster, which is a new topology, clustering topology introduced in 12c. So this is the agenda. We've allotted 2 hours. However, I've learned how to compress video. So the demos have been recorded, and I've compressed them down, in some cases considerably, so that we can move rather quickly. But here's the agenda. I'm going to do a quick, very brief review of what Oracle Clusterware is and some of the properties of Oracle Clusterware as it exists in pre-12c. Just a simple slide. I'm not here to overwhelm you with marketing architecture or slides that basically go into great detail of the new features. We're focusing only on the Flex cluster. However, I do have a slide that kind of highlights what the new features are in this particular area for the grid infrastructure. And then I want to get into the demos. So I'm going to describe the Flex cluster 12c. We'll do a time-lapse demo of an install, going through the installer so that you understand how familiar the install process is in 12c. Much of it is very, very similar to pre-releases of 12c. However, there are some minor changes that influence the choices that you make and the architecture that you'll get. And then, time permitting, we can do a quick add node. Again, time-lapse demo. Time-lapse is that these are rather large clusters. So I start out with an install of a 7-node cluster and expand it to 9 nodes, I believe. So rather than having to copy the binaries out to all of the nodes and sit there and watch the screen, I've collapsed the presentation down through modifying the clip speed. And then finally, the demo that I'm actually interested in is this use case demo. The question really is, under what context would you deploy a Flex cluster? And that's the purpose of the use case demo. So grid infrastructure, for those that are not familiar with grid infrastructure, or rather Oracle Clusterware. Oracle Clusterware is one of the components in the GI stack, which is shipped separately from the database. So it's a downloadable binary zip file from OTN on the Oracle Clusterware page. Oracle Clusterware is one of several components, so one of which is ASM, which is the volume management for the database. ACFS, which is the clustered file system. We also offer, bundled in the grid infrastructure, a database quality service management, which is essentially workload management for the database. And then as of 11.203, we've been providing standalone application agents for Siebel, Golden Gate, PeopleSoft, as well as some Apache products. And these are generic agents that run currently on AIX, Solaris, and Linux. They're standalone as downloadable from OTN on the Clusterware page. However, as of 12c, we actually bundle them as well. So they come shipped within the 12c grid infrastructure home. And then finally, most of you are probably familiar with the Cluster Health Monitor. That is also another component of the grid infrastructure. There has been some minor changes to the licensing associated with some of the components, specifically Clusterware and ACFS. Clusterware is now free to download and use anywhere, so you can protect any application in any environment free of charge. If you require support or patching or upgrades, you will need to have some licensed priced product in the stack so that you actually have a CSI number that you can come in on to get support. For ACFS, that too has a modified license. The basic features of ACFS are also free of charge to use. However, if you intend to use some of the more advanced features like snapshots or tagging, it would be a priced product. So Again, for the uninitiated, Oracle Clusterware is an enterprise-class clustering solution embedded in all of our engineered systems, Exadata Exalogic, Spark SuperCluster for the database machine, and the Oracle Database Appliance. In its history, it was originally purpose-built for the multi-instance real application clusters database. Essentially, it's a clustering solution that protects and manages a very complex active-active write-intensive application, the database. And because of a distributed global cache and the ability for any instance to write to the shared storage, we needed a rather rigorous shared consistency, shared data consistency model to protect against split brains, correct split brains, and possible corruption associated with that. Given the success of Oracle Clusterware in that space, we, from the very beginning, had opened up an API that customers could use, leverage to protect any application. And surprisingly, we really hadn't anticipated this, but customers actually leveraged it. And they began to write applications or agents of their own and hook them into the Clusterware for HA. Over the period of the last 6 years, we've evolved based on customer demand and requirements to become a general purpose clustering solution for all applications. We're leveraging the dependency models and the policy engines that you've come to know in the database space for the application tier. And there's some advantages to a standardized clustering solution in both tiers, which I'll describe in subsequent slides. But essentially, having a multi-tier integration between these is advantageous for finer-grained high availability. General properties in Clusterware as it exists pre-12c, it's tightly coupled. As I mentioned, we needed a mechanism to preserve and protect a consistency across a distributed global cache. So it's tightly coupled. All nodes communicate to all nodes in the cluster, and all nodes see shared storage, and they're heart-beating across the private network, heart-beating across down to the disk. This is essential to monitor, detect, and protect against split brain scenarios where a network partition of the cluster would allow multiple instances to write independently to the shared storage. For those that are familiar with Cache Fusion and the way Cache Fusion works, essentially the application, real application clusters, manages and coordinates the writes to the shared storage. So we need some means to avoid multiple clusters from forming simultaneously and to determine which is a suitable survivor cohort in the event of a split brain. So any subset of servers can form a cluster. We don't need to establish a quorum for survivability. Oracle Clusterware is portable, so across all major platforms. No OS kernel changes required. And we are entirely fault-tolerant, protecting not just infrastructure, but also process groups and resources necessary for the availability and performance of applications. And lastly, we support rolling upgrades. So you can move through, without taking downtime, move through an upgrade of the clusterware, node by node. So looking at a simple block diagram, these are the basic components for Node Cluster. You've got 4 instances of an ORCL database. Each of them are running an ASM instance. All of them have shared access to storage and peer-to-peer communication by a private network through an access layer switch. Our requirements have somewhat evolved, particularly for this type of deployment, shared storage, public and private networks. For the database tier, we require 3 IPs for the cluster aliasing, as well as a virtual IP for each node in the cluster. We need some sort of host resolution, either via DNS, GNS, or SE host definitions. We require multicasting or broadcast functionality for discovery of communication endpoints among the peers. Because we are running some things, particularly the infrastructure that would be owned and managed by root, we need root access either through sudo or root itself. And then some secure, efficient means of shell interface between the nodes, SSH or RSH, and then sundry miscellaneous systems configurations. Pre-12c, we have introduced a number of features and functionalities that I won't go into detail now, but I think it's important that you appreciate where we're headed. And things that we're doing in 12c will become much clearer if you take into consideration what we've done in the past. In 11g, we introduced server pool partitioning of the cluster, allowing you to logically partition the cluster into distinct pools managed and role separated for different functionality within the cluster. You could partition different databases. You could partition the database and the application, each of them separated through role management. So there's ACLs defined within Clusterware to prevent management in one to interfere with management of another pool. Using these server pools allows us to abstract and implement policy management or resource management. So compute resources can be distributed across the cluster or managed within a pool or between pools. I've already mentioned the fact of role separation to allow for multiple admins to work in the same environment without stepping on each other's toes. Some of you will be familiar with our migration to an agent framework for the management of resources in the cluster. It's much more efficient than the script base that we had been using previously. And we've actually extended this framework for customers to write either through a script agent or introduce in 12c a generic agent to plug in any application easily into our HA framework. We introduced cluster file system. Obviously, services at the database tier is a means of abstracting client connectivity. All of these things are building blocks for what we're doing in 12c moving forward to ease of management, high availability, and flexibility and scalability. I won't go into these others. We can address them in Q&A if necessary. This is just a snapshot of what we've done in 12c. And this is in red purposely because it was like squeezing blood from stone. We worked very, very hard on this release. We introduced a lot of new features and functionality at the request of customers, either through the customer advisory boards, betas, or one-on-ones with customers and CDCs. This is essentially a list of things that customers have demanded us to implement in our grid infrastructure. And in this presentation, we're only going to focus on Flex Cluster. And as a result of some of the demos, we'll look at this what-if analysis that allows you some degree of predictability of functionality within the cluster before you actually execute something. And then we introduced HANFS. I happen to be using it in one of my particular demos. I'll point that out, as well as the generic agent, which is an easy way of plugging in an application. I'll point that out as well in the use case demo. So comparing the Flex cluster general properties to what I described earlier for the standard cluster as it's come to be known, the Flex cluster is essentially combining the tightly coupled clustering of the database tier with a loosely coupled server membership in what we call the application tier. And specifically, you'll come to know these names, Hub and Leaf. The Hub is what you know as the database tier, and the Leaf is the application tier, at least in this initial release. So we've combined a tightly coupled and loosely coupled clustering solution in a common cluster, which is rather innovative. And this topology allows us to much more efficiently scale to thousands of nodes, literally thousands of nodes. And we are able to retain all of the policy management that you've known in 11g, as well as the other functionality such as server pool management. In the hub servers, the hub and the leaf are essentially roles that are attributed to particular servers in the cluster that have specific attributes, if you've so configured it that way. So the hub servers, as I described before, are basically the database tier. They are tightly coupled, preserving all of the properties of the tightly coupled cluster for database processing, multi-instance database processing. What's new to this topology for the database tier is FlexASM. Now, we're not going to go into detail on FlexASM. I'm absolutely sure that you'll have a RACSig presentation on FlexASM, but this, too, is innovative technology in terms of volume management, where we can only deploy at most 3 ASM instances in a cluster, where you no longer have the tightly coupled database and ASM instance co-located on a single cluster. You can actually get extent map service remotely from a peer in the hub tier. So I'll leave FlexASM to another presentation, but we're very excited about that particular feature. The leaf servers are lightweight servers. There's no database, there's no ASM. The footprint in terms of CPU consumption is very small. There is no peer-to-peer communication as there is in the hub servers. There's a simple, loosely associated peer communication of a leaf node to one hub node just to communicate and protect against failure. And in this initial release, these leaf servers are intended to be dedicated to application service. The Flex cluster supports intra-tier dependencies. So, for example, you're familiar with the database tier and management of resources across the database cluster. We've extended that intra-tier dependency model into the application tier where, for example, you may have multiple application components that operate in distinct management domains. So it could be, for example, PeopleSoft, Tuxedo, and WLS, which each have their separate management domain. However, there is no mechanism to coordinate a dependency between each of them. Oracle ClusterWare 12c allows you to do that, where if you start up PeopleSoft, within the application tier, it will pull up all of the other dependencies associated with it. And inter-tier dependency, which is essentially defining dependencies between the application and the database tier. So, for example, if the database comes up and the application is not up, and these components associated with the application are not up, the database will pull up the application, and vice versa. If the database is down, or the service associated with the database is down, and the application starts up, it will start in the database tier. It will start up the database or the service. And finally, another innovative element in Flex Cluster is the ability to deploy bare metal and OVM servers in a common cluster. So essentially, you will have the database tier running bare metal, and you can deploy either bare metal or virtual VM guests, OVM guests, in the leaf tier. So that provides us with a far greater rapid deployment, build up, tear down of servers as needed to provide availability for elastic demand. So this is what the topology looks like in the demo, and you see that the rack pool, which is the hub tier, are a 4-node cluster with the ORCL database running across all 4 nodes, and we're only running 3 FlexASM instances. The ORCL4 would be getting its extent map service remotely via an ASM network, which you'll see in the installation process. It will get remote service for the extent bitmap from a peer node in the cluster that actually has the ASM instance running, which is just a brief word about FlexASM. What is particularly interesting about this is the availability for 12c databases, and that if the FlexASM instance fails on that node, the database will not go down. We have logic in the calls down into the ASM tier to determine, oh, there is no ASM instance running here. Run a remote exec to a peer node that actually has the FlexASM for my extent map. The leaf tier is, as I described it, there's no shared storage here. The processing over the network essentially is a heartbeat mechanism just for viability in the cluster to a hub node in the cluster. There is no public network defined by default. You will, as you'll see in my output in the demo deployment, you will see a secondary network configured exclusively for the use in the leaf tier. I've only got a single leaf pool partition here, but I could have easily partitioned this out as I added nodes to contain multiple pools for the leaf tier. So, for example, you could segment the application tier into different applications, and you could even have a Golden Gate extract or replicate process running here in a distinct pool on a leaf node for replication of for the database. With that said, I've got two demos. They're time-lapsed. You'll see that in the first demo, I'm assuming that everybody can see this. I purposely included a clock in the upper corner so that you can see the time lapse, but essentially I condensed what was approximately an hour and a half installation for a 7-node cluster down to, I think it was 20 minutes, less than 20 minutes, 17 minutes. So we can move quickly, and I purposely recorded this so that I could do that condensing of the video. But also we can move back and forth if you so require to look at different parts of the installation so that you become more familiar with it. And yeah, I felt the video was better than snapshots of slides because you can appreciate the workflow a little bit better. But let's get started. So most of you know this is Linux. In fact, it's virtualization. We've been supporting multi-instance rack databases in OVM for some time now. This is an environment that allows us to deploy and do functional testing and demos pretty easily. It is Oracle Linux. What's important here is that we are now providing an RPM for pre-install RPMs for 12c as we did for 11g. Okay, let's get going. And I'm moving pretty quickly through here. So just running a quick cluster verify. The advantage of the RPM, it sets up a lot in advance, but there are still some things that you need to set up, like permissions on files, the ASM disk groups, etc., as well as user equivalency between the nodes. I purposely left SSH out so that I could just do it during the installation process. So I have not set up SSH here, but if I wanted to, I could easily run this command that sits in the distribution of the grid infrastructure software. So let's kick off the install. Some things that I want to double check on are the permissions and ownership of all of my disks to be used for ASM, and then the permissions of my Oracle Base and Oracle Home. So just want to be sure that those things are correct. And now I'm just going to run the installer. It'll move pretty quick, don't worry. You'll see that you'll be very comfortable going through the install process because it's very familiar. And I suspect most of you have only gone through the installer once or twice. Once you understand the workflow, you leverage the silent installs and response files. So that's why I chose to go through the installer this time rather than demonstrate a silent install, is that you can understand a little bit of the workflow. So this is a familiar. I'm not going to get the updates. This is familiar. It's basically the standard installation option page. The cluster type page, however, is where we start to introduce options with regards to the type of cluster that you want to deploy. Standard clusters, which you're familiar with today in 11g. The Flex cluster is the highly scalable hub leaf architecture for application and database. So language, Okay, this is, again, familiar. However, a little typo here, and it actually thought that I had completed the interview for this particular grid plug-and-play, but I hadn't. But this is relevant. GNS is now required for Flex Cluster. However, it's not GNS with subdelegation out of DNS. This is GNS only to discover communication endpoints in the cluster. So you will need a GNS, a virtual IP, in addition to the other IPs required for the cluster deployment. So this was a demo that I'd done for Boeing, so that's why Boeing shows up here. I enter my scan address, scan port. I am not using DHCP, so this will be static addressing. I enter in my IP address. I modify my DNS subdomain, and I want to verify that I've got my IP addresses correct. You can't see this, but basically just want to be sure that I had the scan name correct. Okay, so moving forward, this is yet another stage that distinguishes Flex from standard cluster deployment. We now ask you to define the role of the server in the Flex cluster, hub or leaf. It's pretty straightforward. So basically, I use a config file. There's a minor bug here that the config file doesn't yet allow you to define role that's being addressed, as you'll see it in a patch. When you define a server as a leaf, notice that we are not requiring the virtual IP. So this is essentially the attributes of the leaf node. No virtual IP, no shared storage. As I mentioned, I did not configure SSH, so I'll just do it in the installer. It will run SSH, distribute the keys across all nodes in the cluster, hub and leaf. That worked. Great. A little sync time on my part. 1 moment. And now I'm going to run some CPU checks to validate the environment. Validate that the SSH is working correctly across all nodes in the cluster. Sundry other validation tests. And if you recall, we're deploying Flex ASM as a requirement for Flex Cluster, and because of remote extent map servicing, ASM will have its own ASM network, which you can co-locate or combine with the ASM private. So the pull-down options here would be public, ASM and private, or just ASM. You can decide. I chose to use both the ASM and private. Very little traffic associated with the Flex ASM processing. And again, extent map is not in the critical path I/O. This is new, the Grid Infrastructure Management Repository. If I decide not to, it's a singleton database repository, which we use for cluster health monitoring, workload management associated with quality of service, and memory guard, as well as sundry other features that will be coming in later releases. If you elect not to install it, you will not be able to take advantage of those features. I chose to install it. This hasn't changed. Essentially, it's just string definitions for ASM. It's a familiar cluster, so I kind of cheat and use a single password for both. No IPMI. Those are my default groups. My Oracle base and software locations, just taking the default. Validating that those are correct in terms of existence and permissions locally and remotely. Okay, moving right along. Inventory definition, great. All of this should be very familiar with those that have stepped through the installer. This is NuDi 12c. Can you imagine if we're talking about deploying thousands of nodes, having to log in to each node to run a root.sh? So it's about time that we've offered automatically running root.sh across the nodes in the cluster. So that's essentially what this interview is the root script execution. And obviously, you're going to need to present or provide the root credential or sudo credentials. And you'll see the execution and how to monitor the execution of root.sh during the install. So our clock is ticking. Okay, so this is a familiar environment. I know my physical memory swap and limitations. It's not going to impact this particular demo, so I choose to ignore these alerts. However, we do provide fixable or fix-up scripts for check actions that are checks that may have failed that we can fix. And in fact, you'll have the option to fix and check again, and you'll run a script which will execute globally on those nodes that are affected by the failed action. So in my case, I had no real failed actions that are fixable, so I've chosen to ignore them. So moving through, yep. Again, response file, you'll see the Flex cluster specific things associated with GNS, hub leaf node definitions, the roles of each of these servers, etc. Well, here we go, just kicking it off. Going on the product. I was a little paranoid during this install. I thought that I was seeing an abnormality in the permissions of the Oracle base. So you'll see that screen pop up quite a bit. There was no problem. I was just getting a little paranoid. So extracting files, standard stuff, linking binaries, the setup, and as we all know, for anybody that's done the GUI install, we hit that 57% mark where we start to do the global distribution of the binaries. So yeah, that's where we see a lot of speed up in my video here, rather than having to sit there and wait for the copying of the Oracle Home. That said, you will see some exciting things coming up in future releases to address this kind of distribution of binaries across cluster. Some really exciting things, which I can't mention in this call. But let's get to the install. Let's get to the root.sh. Again, I'm just popping up, checking the permissions, be sure that there was nothing wrong there. Patience. Take note of the subliminal advertising down here on the right. Okay, so setting the inventory. Now we're going to execute, just setting the inventory. This takes a little bit of time too. But here we are going to execute the root.sh scripts. So click yes. Remember, we've already provided the credentials for root. Down here in the lower right, you'll see that we've started the root.sh on the node that we're actually doing the install on here, which is node 100. So I'm going to go in and run a tail on the execution. So under the CRS config log file, which is tail -f, as I see the execution of root.sh. And basically, checking certification, populating keys, loading kernels, creating links for the OHAS stuff. I'm not going to go through this in detail. In fact, I may do a RACSig presentation on this separately, just deconstructing the root.sh so you understand the flow a little bit easier. But let's just let the root.sh run. You'll see that there are iterative starts and stops as we're transitioning from local OHAS to cluster CRS from exclusive mode to global mode. So we bring the stack up and down a few times, particularly on this first node, as we're populating the keys, verifying the reads and writes of the OCR and voting, etc. And instantiating the voting disks, creating the ASM disk groups, all of that stuff you'll see as you go through the root.sh. Even though we allow you the possibility to execute kind of under the covers, I just need to see that it's working. So I've got to, at least in the first couple times, you want to do a tail minus F on this particular log file. Okay, just running some wallet and certification checks. Now we're attempting to start up the whole CRS stack. What are we doing on time? Okay. Given that we're at 10:40, okay. Okay, populating some of the resources, firing them up. You'll notice references to Hub and Leaf. So we are running the root.sh. This node has been configured to be a hub node. Okay, starting up some of the node apps. You'll see a lot of checkpointing, too, which we introduced in 11. If you recall, we checkpoint the execution of root.sh for restartability in case it fails. Okay, yet another bounce of the stack, and we'll bring it up as a global stack. Okay, bringing up a proxy ADVM. In fact, this is the check action associated with the start of the resource. So we'll just loop through this until we actually determine that it's online. Not to worry. It comes online, believe me. Okay. There we go. So you'll see that success, we like success. And now we are starting on the other hub nodes. We'll start the hub nodes first, and then the leaf nodes. A leaf node cannot start up unless it can communicate with a hub node in the cluster. So essentially going to do the same thing on a couple of the other ones. It's always the first root.sh because there's a lot of overhead in creating some of the structures associated with the clusterware on that first node. Root.sh runs faster on the other hub nodes subsequently, and even much faster on the leaf nodes because it's they don't have these resources. So inventory updates as well are faster. Okay, so I'm just going to start it up in a clustered mode. 6 minutes and counting. Okay, so we've started it up on the other nodes in the cluster, in the hub tier, and now we're starting the execution on the leaf nodes. Remember, there are 3 of them, so this is a 7-node cluster. I do have an add node demo, and essentially the add node is doing exactly what it did pre-12c. It was just to include that to demonstrate that there's nothing fancy. I'm actually adding leaf nodes, and there are some efficiencies because of the way the leaf node is architected. It's just there's not that many resources, so it's much more efficient in terms of add node than previous releases. We'll skip that demo because we're quarter to 11. If there's time after, I can go back to it. But here we've got success on the leaf nodes too, so the stack is up and running. Now we go through some of the configuration agents. We update the inventory, run the netconfig assistant, as well as the management database. So we need to start up the management database. It's a singleton database running in the cluster for cluster health monitor, aggregated system-wide metrics associated with the cluster performance. Step through it. Everything looks good. Let's see, I'm on 106. So this is the top of 106, and you'll see that there's not a whole lot running here. 106 is a leaf node, so we've got the grid IPC for communication, OSD. You'll see an OCSSD RIM, which is specific to the leaf node. So this is CSS, so the cluster synchronization services specific to the leaf and hub communication. And then event management and a lot of the OSYS1D stuff. So we'll compare this top output to top output on hub node. Actually, I want to see the startup of that management DB, so I should get out of here and go to node 100. So here, you start to see the management DB starting up with the set of management D. Okay, so waiting for the configuration assistant to complete. We're getting there. Then once this is installed and completed, let's take a quick look at some of the OLS nodes output for the CSS topology of the cluster, as well as OCR and the resources to CRS CTL stack. Okay. And the final CVU checks. Be sure that everything is running properly. Okay. Now, looking at OLS nodes output, you'll see that we've got the 7-node cluster, 4 nodes hub active, 3 nodes leaf. We look at the CRS-CTL output. You'll see some things specific. Here's the ASM listener associated with the ASM, the Flex ASM communication only on the hub nodes. You'll see that the core network, the Net1 network, is exclusive to the hub nodes for database purposes. The leaf listener is a listener for EM Cloud Control Agent. Other things we've got here, standard scan. Got a management listener for the management DB. See that we've got the 3 ASM instances on a 4-node hub tier, so we're only running with 4 ASM instances. We have the Aura.management DB resource, and then our standard node apps associated with networking. Okay, that is that demo. And this first demo, I'm assuming that everybody can see this. I purposely I will defer the add node. It really doesn't demonstrate anything other than the simplicity of adding a leaf node to the cluster. And the workflow is essentially identical to P12C add node functionality.
Hello, my name is
So let's move into our use case. What I've done is I've taken the Flex cluster and for purposes of demonstrating the co-location of the application and the database in a common cluster while preserving the security and role separation associated with each of these tiers. I've taken Swing Bench order entry. It's an OLTP type application. Most of you are probably familiar with it. It's an NGDPC connection with about 40% read, 40% write, 60% read. And I've deployed that in a Flex cluster where I've got 4 nodes servicing the database, 3 nodes for the application tier with Flex ASM.
What is cloud?
And I'm leveraging the agent to protect the Swing Bench app. So I'm using the script agent to manage the order entry application within the clusterware, and the generic agent to protect a mount point where I store the Swing Bench binaries, metadata, and trace files.
For consumers,
and the actual script, my action script is sitting in
a self-service manner where they don't have to wait for IT to
so this is what this policy looks like.
Self-service portal quickly provision what they
7-node cluster
when their needs are no longer there. In order to satisfy these requirements, what customers are looking for is a solution that can help them define and manage data center resources as services.
Instances here, 3 Flex ASM, Hub Leaf Pool. I've got my Swing Bench app running up here, which can move anywhere among these 3 nodes. I've got an associated service, and so I'm making my connection by the service to the ORCL database, which could float around between these nodes in the cluster. In fact, in a previous demo I'd done, I used a PDB. So I configured, used a PDB for the order entry demo. And in fact, I'll probably rebuild that for OpenWorld. So I'll run multiple instances of the order entry across the leaf node, hitting PDBs in the database tier. Now, this is interesting because I'm using a standard cluster, not for database, not for application, but leveraging a huge amount of storage that I had, providing ACFS shares via NFS, HANFS, as my swing mount point to the application tier. So I've configured HANFS to provision these ACFS shares via NFS to the application tier, where they're actually making a connection through an HA VIP for NFS. In addition, each of these mount points on each server are protected by the generic agent. So I'm doing check actions to be sure that the mount point is up and available before I even start the application. And if it fails, I will attempt to remount it. So this is the topology, basic hub leaf, implicit server pools, implicit meaning that when you configure Flex Cluster, you'll get a leaf pool and a hub pool by default. No shared storage here, associated heart feeding to server in the hub tier. No interleaf communication. So these guys do not heart feed. Unlike the hub tier where there is peer-to-peer heart feeding between all nodes in the cluster across the network and to the shared storage to be sure that all nodes are viable, that's not true for the leaf tier. And then I've already described the standard cluster. So this is what the demo looks like. Basically, I'm going to start up the SOA application resource, and it has a requirement, dependency on the virtual IP for the network, obviously, but also for the database tier, which I've configured the dependency on the service. So if I start the SOA application first, it's going to pull up the database service as well as the virtual IP before it starts. Then I will fail over or actually relocate, or let's just say planned maintenance, I relocate the order entry application. It will pull over the VIP and will start at the application. And I'll move it back. Then I'll relocate the virtual IP, and it will pull over because it has the hard dependency on the order entry. Notice that nothing interferes with the database tier. There's no interruption of service at this tier. So let's play around with the database tier. Excuse me, I forgot I faulted. I did a dirty reset of the server providing the order entry application, and it fails over to another surviving node in the cluster. So a little maintenance in the database tier. Let's relocate the service. Fine, no failure of the order entry app. And I dirty reset the service. It fails over. Order entry app is still running. So with that, just to map out the dependencies for this particular demo, this is my order entry application resource. And it has a dependency on the service, which in turn, internal to the database tier, has a implicit dependency on the database. The application has a dependency on the virtual IP, so clients can connect to the application itself. It in turn has a dependency on the underlying Aura network. Notice that I created a Net2 network because the Net1 network is occupied by the database tier. So I created a distinct application tier network. And lastly, I've got a file system for the Swing Bench application, where I mentioned that I store the database. I have a dependency on that where I protect the mount point via the generic agent. So let's take a look at the demo. So this is not time-lapse. So this demo is a 13-minute demo, and I've got a lot going on here in terms of screens, which I'll explain to you. In the upper right-hand corner here, I do an OLS nodes to take a look at my topology. This is different clusters. So I've got 6 nodes, actually 7 nodes. 4 nodes are hubs, 3 leaf tiers. So what I want to do for the purposes of this demo is just loop through the clusterware view of the topology. So as things change, we will see it reflected in the output of OLS nodes. Then I'm going to bounce over to another screen and take a look at the resources. Everything's in a stable state. If you recall, I've partitioned a network, so I've got a Aura 1 network for the database tier. I've got an Aura 2 network for the application tier. Here's my mount point, which is exclusive to the leaf node. And looking through. Okay, and obviously the database. Here's my GNSDIP as a requirement for Flex Cluster. Here's the database. Here is my service associated with the order entry. Notice that it's offline. Here is my application associated with the order entry. Notice that it's offline, and the database, the order entry virtual IP is offline. So what I'll do now is bounce back to my other screen, and I'll loop through a CRCTL on the relevant resources, so filtering out irrelevant resources, because I really just want to take a look at transition changes of the resources that we're focusing on, basically the application tier, the database tier, some services in the database, as well as the application BIP. So looping through, this is basically the command that I'm running here is a filter on ORCL and Swing. Down here is just a tail on the log that I have in my script agent, which is running on node 86. So I'm basically taking a look at the check actions that I'm logging in the execution of my script, my action script. And then in this window, basically going to loop through some select on GB$ session, GB$ instance as the application makes a connection. Up here, I'm executing commands. Notice that the new syntax here with eval, this is the what if that I referenced earlier. You are now in 12c able to execute an evaluation of a command to anticipate or predict what will actually happen. So if I want to start up this application, what should happen in the execution? What nodes will it run on? What are the dependencies that will be fired up associated with it? So looking at this, it will execute essentially in two stages. The Swing app resource has dependencies on the service and the VIP, as I indicated earlier. So what's going to happen is the first stage of execution will be to start up or pull these up because of the explicit dependency. So it will start up the service on 83, which is a hub node for the database, and it will start up the virtual IP on node 86, which is a leaf node. And it will co-locate the application with the virtual IP. So let's start it up. And you will see the transitions in this window over here. So go ahead and just start up we've already got the virtual IP fired up and the service is fired up. This is real time. It's pulled up, and we'll bring the application up. And it's on the nodes as expected, and my start and check action fired up down here. Okay, so inter-tier dependency. And down here we see the connections coming into the database, inactive transitioning to active. Okay, so now let's start to play around. I believe we do some relocation. So back up to my window. I'll evaluate a relocation. Want to know what happens. Now notice, I get an error. This is to demonstrate that what actually is evaluated is a true reflection of the execution in the code. We have a dependency here, and these resources are already running. So if I want to do a relocation, I have to force the relocation because of this explicit dependency. So I need to pass in the force flag. So if I do redo the evaluation, pass in the force flag, we'll see that we will relocate we'll take the application offline, we'll relocate the virtual IP, and we'll bring up the application online once the virtual IP is up. So in the third stage, the application will come up, and they will be co-located on 85. They're currently running on 86. Okay, we transition from 85 to 86. Great. No surprises. You'll see that we will fail over the connections. Now notice, this is just basic connectivity associated with pre-12C. This is FAN. This is Universal Connection Pool. In 12C, we introduce Application Continuity and Transaction Guard, which is a mechanism for higher availability to preserve state and failover connectivity at the client tier. So it's a different JDBC driver, different configuration, and you would not see this type of failure. In fact, what you'd see is a pause and then restarting of the connection. You would not see cleanup of the connection cache and reestablishing connections on the other node. But for our purposes, I'm just using the standard FAN UCP connectivity. Okay, so the next, I believe we were relocating back to 85. And you see the transition. Hold on, what did I do there? Yeah, okay. Yeah, relocated to 86. I'm going to go to 86, and this is when I want to do the dirty reset. So need to check something here. Well, this is real time. I didn't edit this video, so this is real time mistakes, if you will. Think time on my part. Now, where did I put that shell script? So I'm actually on 86, which is a leaf node. Clusterware commands are single system imaged. So you can execute a CRCTIL command anywhere in the cluster as the grid admin for any tier, so the application leaf tier or the hub tier. So what I'm doing here is actually going down to find out where I left my kill script. So I found it. I'm doing a dirty reset on the server. So I'm going to kill the server where the application is running. So you'll see up here the node 86 transitioning, well, it will disappear. There's no recovery necessary here, no reconfiguration of the cluster. The leaf tiers can depart and rejoin the cluster as necessary without imposing a complete reconfiguration on the database tier of the clusterware. You'll see transition out down here as well. So this is, again, a VM environment running on single core for each of these different guests. So the dirty reset takes a little longer than it would in a real environment. But you'll see that 86 transitions out of the cluster here. It's normally, dirty resets don't behave this way. It's an anomaly of virtualization. Okay, so 86 is gone. You see that we failed over from 86 to 85. The application is still there. You'll see the connections transition from inactive to active on node 83. Okay. So now, I recall we will go down to the database tier. Keep an eye on this window occasionally because you'll see that the leaf node will rejoin the cluster on its own. There's nothing I need to execute. It will discover as it restarts that, oh, I'm a cluster. And I'm a member of a cluster. What's my cluster, and how do I join? So it joins by itself as a leaf node. So here, formatting's a little off, but here I want to evaluate the relocation of the service. What's missing here is I didn't actually describe this very well, is that I'll relocate the service, but there's dependency on the application. So you'll see that the service will relocate off of 83, but the application event won't be influenced. It scrolls up very fast, but all that's shown here is the application. There's actually another stage up there. So let's do a force relocate of the service. So we're moving from 83 to 82. Again, isolated to the hub tier. Databases will only run on the database tier. Applications will only run on the application tier. And we transition the connections. Now here I'll do my dirty reset of the application tier. Dirty reset of the database, which is node 82, where the service is running. Again, anomaly of VM. The dirty reset takes a little longer than in real life. Notice that 86 has rejoined the cluster. And you'll see 82 transition out. Now, this is the database tier, so everything that you've come to know and love about reconfiguration and recovery of the database still remains true. I mean, there are some new efficiencies. However, we still need to reconfigure the cluster, identify the mastership associated with the database blocks and buffers, and reconfigure and pass the topology back up to the database tiers. So we're now running with a 3-node database tier. The service is failed over. The database on node 82 is offline stable. And you'll see the client connections reconnect, move into an active state. Those are client reconnects. And what's interesting at this point will be the transition of 82 from inactive to active hub. So that's CSS's vision of the cluster topology. Then you'll see a transition of the database instance on 82 transition from offline to online, stable. You'll notice the clean action and starting. Because this was a dirty reset, the clusterware will execute clean actions associated with the database to be sure that it's in a sane state before attempting to restart it. Database recovery is already taking place at this point. So this is just bringing the database instance back in to the clustered environment. So in the next, let's see, 3 minutes, you'll see this transition. And for those of you that are planning to see transition to the cleaning state, then we'll transition to starting and then open stable online. For those that are planning to attend Open World, I plan to have a more elaborate demo along the same lines, perhaps a little easier to follow, but demonstrating this intra-tier dependency model and inter-tier dependency model for a common cluster, a common Flex cluster. So going through starting, and as you review the slides in replay, in the 12c new features and functionality highlights, I'd suggest you can evaluate those based on white papers and documentation, and ask RACSIG to ping us if you're looking for something specific that you'd like us to drill down on. Obviously, FlexASM is a component. Multi-tenancy and RAC certainly would be something that you're likely interested in. But drive this through RACSIG, and we'd be happy to put together and talk about it. I personally intend to have a more detailed internal description of Flex Cluster probably after OpenWorld. So this is essentially this use case demo. We're waiting for the transition to database from starting to open stable. That's going to happen. That's essentially all I have for this one. Let me defer the add node, and we can simply just open it up for questions at this point. I see that Marcus has been addressing some of them in the chat. Okay, so our database instance on 82 is open and stable. So we've returned to steady state. Now I'm shutting things down. So, okay. With that, are there any questions?
You have one audio question from Larry Wilson.
Hi, Larry.
Hi. So all the servers have the same root password?
All the servers have the same root password. Yes, because at one level you need SSH connectivity. It's a requirement in the cluster. What's the use case where you might have different root passwords? So root password for the application tier might be different from the database tier?
Yeah, I don't know. I just wanted to make sure. That's what I thought I saw earlier. So.
Yeah, I guess our assumption is that you've got one trusted admin here, and that's the guy that controls the grid infrastructure. So we'll call him grid admin. So he's the guy that essentially would be at the infrastructure level managing the root access and manipulation of root-related resources between the tiers and within the tier. So that's our assumption. If there's a use case that requires a distinction, I'd like to know about it. Maybe you can drop me an email.
Sure.
Okay, thanks.
There are no further audio questions.
Oh, no. Come on. There's got
well, we have a few questions on the chat, John, and I think it would be useful if you could perhaps elaborate on the relation leaf nodes to hub nodes and how they fence. Is there a voting disk? And, for example, what happens if a hub node fails? These were questions that came up in the chat more than once.
Oh, sure. Okay. So the fault and fencing semantics associated with the leaf node are very different from the hub node. Hub node, essentially no change. It's tightly coupled. We have to preserve against or protect against stray writes that could introduce corruptions due to a split brain. Between the leaf and the hub, there really is no concept of a split brain per se. It's a leaf node heartbeat to a hub. If the hub goes away, the intent is that the leaf node will have a grace period to reconnect to a surviving hub node. So you will see, like, miscount kicks in. And the leaf node will be aware of that. And the leaf node will say, okay, I've got a grace period here that I will establish a connection to something else. So it will fail over to a surviving hub node in the cluster. If the leaf node fails, just as you've seen it, it will just restart itself and kick off whatever applications were running on that server to begin with, or which should be running on that server. So semantics, fencing semantics are very different. If we detect that the leaf node is not heart beating, it will be fenced and just simply restart. There is no reconfiguration recovery at the clusterware layer. There may be something inherent to the applications that's running in the leaf tier that requires some recovery, but it's in a different domain. Taking a look here. Could we use GNS or scan weights? What's in 12C? Hold on, I'm looking from S. In 11G, we could use either GNS or scan. Okay, so scan is a cluster aliasing specific to, in this release, specific to the database. So in 12C, scan will be service registration, listener registration for cluster aliasing, specific to the database tier. GNS is a naming service cluster-wide. So there are a couple of things with respect to GNS. In pre-12C, GNS was doing subdelegation with the HTTP for grid plug-and-play, automated discovery of hosts in the cluster. It's automation and simplicity of IP management and name service dedicated to the cluster. In 12C, GNS still performs that functionality, dynamic discovery of hosts in the cluster. However, for purposes of Flex Cluster, we're not imposing subdelegations. You don't need to go and do subnet forwarding through DNS. We just need the virtual IP so that we can ensure that GNS in the cluster is up and running, and we will be able to discover nodes or hosts in the cluster. Is the grace period for leaf node configurable? It will be, yes. The agent demo topology slide, HANFS configured from the standalone cluster ACFS to leaf nodes, the CAN-HA from leaf node to Flex cluster ACFS. No. So the question is, can HANFS be configured from leaf nodes to Flex cluster ACFS? So leaf nodes, the assumption is that leaf nodes do not have shared storage. So there is no ASM running on the leaf nodes. In this release, there is no ASM running on the leaf nodes, and to have ACFS, you would need ASM. So that's a no. Where resources configuration for leaf are stored, as there are no shared disk, OLR. So they have an OLR. And the resources are visible and stored as well in the OCR. Okay, can I have a leaf and hub on the same node? No. You can't have leaf and hub. Those are roles defined for a particular server, and for production purposes, the assumption is that those are distinct servers. Now, in test, QA, functional demo, stuff like I've done, in fact, you could co-locate VMs of a leaf and a hub on the same server. However, that's not supported in production. And in Flex Cluster, the assumption would be the hub would be physical, and you could have a leaf node being a VM in a separate physical server. And you may have multiple VMs serving as leaf nodes for a particular cluster on a separate server. Okay, Oracle Restart. Marcus may be able to talk more about this because it's essentially a database, but it is deprecated. You won't see it going away in the 12C life cycle. We are still evaluating what we want to do about that. Okay, what will run on the leaf node? Well, in this release, any application. So I've given you the use case of an OLTP type application. It could be legacy apps, for example, PeopleSoft, with associated components such as Tuxedo and WOS. You could be also running Golden Gate on these leaf nodes for replication. And as I mentioned earlier, you can further partition the leaf tier into distinct server pools for administrative isolation and management. How the application services move to another leaf node automatically. They are not interconnected. Okay, so this is all managed through the policies driven through the clusterware. The assumption is that you're starting and stopping, or stopping and starting on each of the different nodes. So the assumption there is that the binaries required for the application are available and known to the clusterware, so that when we send the command to start a particular application on a particular leaf node or relocate it, we'll stop it, then we'll communicate to the target node to start the application. So that's how the co-location is managed through the OCR, through the clusterware. Okay, one moment. Is there any cache fusion among the hub leaf ASM? No. There is among the hub. Oh, okay. Is there any cache fusion among the hub Flex ASM? No, but there are certainly some optimizations in terms of processing within Flex ASM, but not cache fusion as you know it in the database tier. So no buffer processing that is database specific. Excuse me, I'm looking through. Because hub and leaf are two separate, yes. In production, that's the supported configuration. And notice, I'd mentioned that you get two implicit pools and two implicit categories. In my highlight slide for 12C, I mentioned server categories. Pre-12C, we essentially considered all servers in the cluster to be identical, standard. We had no means of understanding the compute capabilities of or specific attributes of a particular server in the cluster. In 12C, we introduced server categories, which allows you to, well, one, we will dynamically discover the compute attributes of a particular server and allow you to leverage them in terms of server pool definition. So we will know the attributes of a server, and you can use categories, these categories and slash attributes of a server to drive the configuration of a pool or modification of a pool. So Hub and Leaf are deployed on separate boxes. However, those boxes, we will know what the physical attributes, compute attributes of those boxes are, and you can use those to configure specific pools. How are apps running on the leaf nodes affected by the DB failover to the DataGuard standby? Good question. From the database tier, it is same as it ever was. You're still doing the primary standby transition by DataGuard. With application continuity, if you so configured it and services, we support the transition from primary to standby with no interruption of service to the application tier. Whether you've actually configured leaf nodes or not on the database should be transparent to that transition from primary to standby. So you may have some load balancer or client connectivity that fails on the primary. They would reconnect using the same services and client connectivity definitions as were defined on the primary. So it should be transparent. And it needs to be configured using GNS only. Flex cluster requires GNS. You can configure these. They have to be resolvable, right? So GNS and scan could be defined in the local etc host files of all nodes in the cluster. the critical thing is that we need to resolve the virtual IP requirement for GNS in Flex clusters. Is there any use of coherence in the implementation? There could be. If you wanted coherence, it could be configured. Didn't see any option where you specified OCR. You don't define OCR in voting for oh, good question. Okay, during the installation, I configured ASM, so OCR in voting will be implicitly configured within ASM. Running Golden Gate on the leaf node, where's the shared storage? You can configure shared storage. So, for example, if you needed trail file, shared storage for trail file, in my case, my shared storage was the HANFS shares from an ACFS cluster on a shared non-plane. So that is considered shared storage external to ACFS running in the cluster. So this is a good point. In this release, you will not be able to ACFS provide a cluster file system, an ACFS cluster file system within the same cluster to the leaf nodes. So that's a good question. In my case, I used the shared storage externally via an ACFS share. You could do exactly the same thing within the same cluster. For example, I could, in my demo, I could have configured ACFS in the cluster and presented those ACFS as NFS shares to the leaf nodes. That is entirely supported. Okay, good. Can leaf nodes be used to offload PX? Patience, Bernard, patience. What can be a leaf node? J2E. Yes, sure. You can run J2E applications. I'm not quite sure I understand exactly what that is. You can run a J2E application in a leaf node, yes. No 12C, no, in 12C, no inter-instance communication will happen. I'm not sure what that means. The attributes of the cluster interconnect are these. Cluster interconnect, heartbeats, peer-to-peer, with cache fusion traffic on the hub tier. Interconnect on, in this release, interconnect on the leaf tiers. There is no interconnect connectivity directly peer-to-peer of leaf servers, leaf nodes. There is heartbeating of leaf nodes to the hub tier. So a leaf node will communicate to a single hub in the cluster. And that's essentially for cluster communication associated with cluster metadata, policies, dependencies, start-stop actions, things like that. Yes, there is a way to check which leaf nodes are attached to a particular hub node. The way it is right now, it's kind of a round robin because we will collocate and roll through collocation of leaf to a specific hub. So you'll see in startup 2 or 3 leaf nodes connecting to the same hub and then moving over to the next hub, next hub. There is no interface at the moment to directly see this. However, you can, and I will publish a note either in support on how to determine which hub is supporting which leaves and which leaf is connected to which hub. Will private switch be used for private IPs and leaf nodes? Yes, and that private switch is still a requirement in the cluster for private communication. Of course, we fully support VRAM partitioning of network segments. What is the purpose of the leaf node being connected to a specific hub? Well, it's a cluster, so you need some means of and why have it in a cluster? Well, high availability and management. So if the thing stops or it gets hung or it fails, you want a mechanism to correct it. an automated mechanism, and that's what the clusterware does. Rather than calling some guy to restart the server or losing connectivity and not knowing about it. Also, leveraging a policy engine to automate for higher availability dependencies, the start-stop dependencies between components that bring up the entire stack required for the business. What are the use cases for this topology? Well, in this release, the only use case is co-location of the application with the database. And we understand that some data centers will have a requirement that they have to be separate. Some of them will use the excuse that, okay, they're firewall. So, that in and of itself is not necessarily an obstacle, but they may have standards that require segregation, cluster segregation of the application tier from the database tier. That's fine. For those, we have a different solution. It's an application cluster that is available for post-processing to remove a lot of the resources required of a standard cluster for the database. However, we are seeing, for higher availability purposes and ease of management, customers standardizing on a clusterware for the different tiers and co-locating those tiers in a common cluster. And essentially that's for higher availability, standardization of management, and the dependency models inter-tier. Can we use installed pre-12c database in Flex Cluster? Yes, you can. Remember, though, the Flex ASM is a requirement of Flex Cluster, and only 12c databases have the logic to understand Flex ASM connectivity. So only 12c databases will be able to run on a server that doesn't have co-location with an ASM instance. So for your pre-12c databases in Flex Cluster, you will need to be sure, and it's straightforward enough to ensure that you co-located the pre-12c database with a server that's running an ASM instance. And there are a number of ways around that, but to configure that. You can run Flex ASM. Running Flex ASM is configurable, so you can configure it to run on all nodes in the cluster. Can I configure ACFS and install Golden Gate or Swing Bench and use that as a leaf to not configure ACFS? In the manner that I've described it, either in the demo as an external ACFS share provided by HANFS, or within a common cluster, an ACFS share provided by HANFS to the leaf nodes. Currently, you cannot use the cluster file system in the Flex cluster on the leaf nodes, because there's no ASM instance running it. Okay, insert instance. See if that has leaked to the hub. Sanjoy, I'm not sure what your question is. Similar to what you did from Naris, you use Sandbox, right? Okay, I'm not following this thread. Can you run single node DB on the leaf nodes? Okay. In this release, leaf nodes are non-database servers. So you will not be running a database on the leaf nodes in this release. I appreciate the presentation. It's pretty good. Thanks. Oh, hey, thanks, Megan. SQL servers supported? Yes. SQL servers are supported on the leaf nodes. And in fact, you could use the SQL agent that is available as of 11.204 and bundled in 12c. You get the whole package. You can run the SQL gateway and SQL servers on leaf nodes. Absolutely. In fact, what we expect, and we see a lot of momentum in the field, is the deployment of legacy and web FMW applications on Exalogic, sharing a common or unified ID fabric with Exadata. So here you've got Exadata running the database tier, and you've got Exalogic running the application tier. You would deploy the Flex cluster, extending the leaf nodes into the Exalogic tier over the ID fabric. And you know, that's an Exa use case. That's not exclusive to the Exa family, however. And what's the difference between generic script and script agent? Good. The script agent is available in 11.2. The script agent requires the customer to actually write an action script that defines the start, stop, check actions native to the application and provide that to the clusterware. Now, that script agent can be written in any scripting language or C++. You would register the resource, the application, with the clusterware, defining as an attribute of that resource where this action script lives. That's the script agent. And as part of the check, start, stop, check, we would execute the actions as defined by the script agent. The generic agent is something that other clustering solutions have provided, which is a very simple means of plugging in an application. So, for example, the classic use case might be some of the Unix-level services run out of the NIC or Samba, Apache kind of things. That it's a very simple start, stop, check, where you define via the generic agent interface what the start action is, what the stop action is, and what the check action is. And you've embedded these actions as attributes of the resource rather than having us spawn, parse a script, and execute on it. So it's a very simple, easy way to protect, we think, 80 to 90% of any application out there. Okay, it looks like the rack architecture has been changed fully for 10G or 11G. Yes, there have been some fundamental changes between the 10G and 11G. In fact, I think there's some Moss notes out there that describe those changes. Node GCS or GES comes in the picture, looks to me. GCS, GES, the NQ and cache services are exclusive to the database tier. They're still there, not a problem. From an architectural point of view, with business unit-based Flex cluster hubs, either road to select more cluster storage, DB cluster leaf nodes, horizontal versus vertical. I want to really appreciate this question, Bernard. I'm not sure you're giving me enough information here. I don't know that Flex Cluster is necessarily driving the requirements for clustered storage, because Flex Cluster and the leaf nodes particularly do not require storage. I mean, they probably have local storage. You could run with just the local storage on the leaf node. It's fine. It depends on the requirements of the application and whether the application requires shared storage. In that case, there may be greater demand for clustered storage as you scale out. And when I'm talking scale, I'm talking web scale. I'm talking about the dynamic ability to expand and contract the cluster in groups of tens or hundreds of servers at a time. And very likely those are going to be provisioned as VMs and leaf nodes. So that's our target. Okay. Architecture doc. I should point you all to, for both rack and clusterware, if you go to oracle.com/go-to/clusterware, I've refreshed the site with the Plotly information, and there's an overview of the architecture there, as well as a download tab for the documentation, the agents, and sundry other utilities associated with grid infrastructure. On the rack site, Marcus has also published the Plotly architectural overview. Okay, thanks, Marcus. And there you have it. Is HIIP still supported? Yes. The HIIP is the highly available IP interface for the database. Okay. Yes. why does hub node have to be on physical? It doesn't. That's not a requirement. You can deploy, and we've been supporting the database in virtual environments for some time now. So you can deploy the entire Flex cluster in a virtual environment. And your choice of that virtual environment and the relationship to the physical really depends on is this a production or not. So the rules associated with the deployment of the database, whether it's standard or Flex cluster, still stand. You will not be deploying the Flex cluster, co-locating the hub, leaf, or multiple database instances on a single physical server in production. We just don't advise it. In point of failure, doesn't make sense in terms of allocation of physical resources. Just make a bigger database instance. So I have multiple database instances running on the same physical server. Excuse me. Multiple database instances of the same database, I should say. But we support in standard and Flex cluster deployment on virtual, bare metal, or a hybrid of virtual and bare metal. For applications like OBI, APM, shared storage is necessary on leaf nodes. So, yes, that's fine. So, you would not be able to mount the cluster file system within the cluster as a cluster file system. However, it's still viable via a shared NFS, either internal to the cluster or provisioned external to the cluster. You could still use a NetApp file if you wanted to, or some other external shared file system. Okay, looks like slowed down. Please take a look at Oracle.com. Hold on, what is the minimum number of hub nodes? Good question, Suresh. I've mentioned this in the presentation. A leaf node requires at least one hub node available to join the cluster. And a hub node, a single hub node in the cluster is a single point of failure. So you can run with a single hub and a single leaf. However, you've got multiple single points of failure there. So at a minimum, we would suggest that you run with redundancy at the hub tier, and then however many leaf nodes that you require. In database, not only apps are SAM, not yet. In this release, applications on the leaf nodes. Okay. With that, good Q&A. Please feel free to follow up in the forum. And I did not cover the add node. I think it's pretty straightforward. Okay, great. Thank you all very much.